Thank you. All right, I have 4:20 on my watch, so we'll go ahead and get started. My name is Jennifer Marsman, and I am a principal engineer in the office of the CTO at Microsoft. And so what that actually means, people ask, like, what do you actually do? I actually own three things. So I'm the head of engineering in the office of the CTO. And my team is called Strategic Partnerships. And obviously, our biggest strategic partner is OpenAI. So my team, before I joined, was one of the ones that brokered that relationship. And so now what I do is, one, I research new models. So I'm one of the first to get access to new models from OpenAI and from Microsoft. And I do a lot of capability testing and write white papers and such for Kevin Scott, the CTO, and Satya and such, to help them understand, like, here's what I think it'd be good at, here's what it might not be good at, those kind of things. Two, I work with large strategic partners, so names you have likely heard of, names that are big enough that the CTO of Microsoft has a personal interest in them. And then I just help unblock any technical roadblocks they have and help make them successful. And then number three, I am Kevin's official demo engineer. So I get to write the demos for the CTO. So if you guys have seen the CTO present any demos in the last 2.5 years, you probably saw my code. So what I love to do, like, one of the things I absolutely love is creating demos and, like, trying to figure out how to tell a really compelling story with technology. And so one of the things I got obsessed with a while back was, could I use a machine learning model to cheat at Wordle? Right? I don't know about you, but, like, for me, like, Wordle was this little, like, 5 minutes of joy during COVID, like the little, like, you know, the this is fine kind of thing. I'd be playing my Wordle in the morning and drinking my coffee and just pretending everything was okay before I jumped into reality. And so I got really excited about this as a problem because it's actually got a lot of really hard things from a machine learning standpoint. So we'll talk about all of that in just a second. All right, so this is actually the original slide that I had in an earlier version of this talk. The only reason I left this in, this is, like, all not valid anymore. The only reason I left this in is for this line, to let you know, when I actually did this work, it was November of 2023. So that's when I was actually doing this research. The reason why I left that in is a couple of reasons. So number one, I wanted you to understand that the model that I was using at the time was actually the preview. It was like an unreleased version of what would become GPT-V, which was the early, like, visual model. There was that vision preview that happened. So that's the model that I was using at the time to do all this research, so you know. And now the live demo that I'm going to show today, I'm running that against GPT-4o. All right, so you know what's actually happening behind the covers when we try to do it today. So that's kind of like the continuation of what the state-of-the-art multimodal is for GPT models. Reasoning is a separate thing, so we'll talk a little bit about that too. And then the other thing I want you to know is I'm going to give you the access to the repo. I did put it on GitHub, all the code and stuff that I wrote as I tried these things out. But you guys, I just want to be really clear. It is the ugliest repo you have ever seen. Like, this is ugly, ugly, ugly code. Because what was actually happening at the time is, so number one, when I get access to the models, there's no SDK. Like, there's no documentation. It's a hot mess, right? So this is all, like, straight REST calls and that sort of thing. So you would not, like, if you were going to write this today and you're like, oh, maybe I'll, you know, use her code as a benchmark. Don't. Like, there's a much, much cleaner way to write this code now. And then other things existed, like there wasn't function support back then. So I was like, okay, I'm going to explicitly just make a call, like, in my own little orchestration layer. But now you would use functions or actions or plugins or whatever we're calling them this week. Whatever our extensibility story is called today, that's what you would use to kind of invoke out. So there's a cleaner way of doing that too. So I just wanted to call those out as best practices for writing the code, and none of those are in the repo because none of that existed at the time. Okay? Cool, so that's my disclaimer. All right, so let's talk really quickly about, like, what GPT visual capabilities can do. We'll start there, but then I want to get into the Wordle pretty fast, so let's go through this quickly. So these are actually from an early exploration that I did and gave to someone. Like, we were trying a whole bunch of different scenarios. I'm just going to show you a few of them, but one of my teammates like put this forward and said, what dress is she wearing? And this one kind of blew my mind because it was from the Gucci Spring 2016 Ready to Wear collection. And then I had to go look up the Gucci 2016 Spring Ready to Wear collection because I didn't know. And yes, it was in fact from that, which I thought was like pretty cool. Sports analysis. So this is kind of a fun one too. Just asking questions about like what's wrong with this skier's form. And you can see that the model is able to use a combination of logic as well as a understanding of the image to come up with a pretty good response here. They give a little stuff about like the angle of the knees and leaning too far forward and how you're balanced on your outer ski and such. Circuit diagrams. So this one I did a whole bunch of things around navigation and floor plans and help me do this and navigate the way around the Disney World parks or whatever. So I tried a lot of different things here. This one I had thrown in just for fun, and I thought this was kind of cool because the answer I was looking for was number one, right? That the circuit is incomplete because that's what we would normally say, right? That's the obvious answer there. Number two is actually kind of a best practice, right? So the lamps are collected in parallel, like with holiday lights, when you string them out, one bulb goes out, they all go out because you're breaking the circuit, right? So that's true, that could be a best practice, but it's still not completely necessary. And then number three was kind of cool. The battery might not have enough power, and it's like, oh yeah, in circuit diagrams, we assume that you work out the math so that it does. But anyway, so that was I thought a pretty good answer too. Scene understanding. I am embarrassed to admit that this is Jennifer Marsman's actual pantry, and my kids like way too much sugary cereal. But this is a picture that I took of the inside of my pantry at one point, and you'd notice that it did see that it recognized the three kinds of cereal. It did spell cocoa wrong there. And then it did actually recognize Triscuits, which I thought was kind of cool. This was actually a box of Triscuits, not a bag. But you can see one of my kids just shoved in some like goldfish crackers on the top or something, like right here. So there is like a little like bag-like thing, like right here. You can see somebody just threw that willy-nilly into the pantry. And so it does kind of look like a bag. But just the fact that it got that those were Triscuits, even with the occlusion, I thought was kind of nice. Okay, I also did a whole lot of testing around like scenarios for the blind. I don't know if you guys remember the story of Saqib Sheikh, who does the work on Seeing AI at Microsoft. He is an old dear friend of mine, and I was so impressed. I continue to be so impressed by the work that he and his team does. And so when I got access to this model, I started trying a lot of his scenarios around like currency. Could it recognize money? Could it recognize different images and such? And so I tried passing in this picture and saying like, what was that noise? So not at all related to that, just to see what it would do. And so it did pick up that it was likely a train. And then it also noted a thing about the rural or wooded area, which was kind of interesting too. So pretty good stuff. I also wanted to test color. This is actually going to be relevant later, right? Because color is going to be important for solving Wordle. So I did ask, like, what color is this? And I wanted to use a non-Roy G. Biv color so that it was a little different. So I actually looked up the hex value of coral just to have something a little different and threw that in there. And it did, in fact, say, I put it in I used paint or whatever and just put in the hex number and then put that in. And it did recognize that it was, in fact, coral. So that was great. And then what color the bridesmaids' dress is, it was able to pick up the bridesmaids' dresses are red, the bride's dress is white, and then all of that is accurate. I do question, there is a possibility that the bride's dress is white could have come from training data, if training data was trained on mainly Western culture, because in that culture, typically the bride's dress is white, but there you go. But so far, everything is good. And notice that it is seeing things like within the image as well, not just a single color. All right. Oh, and then this one was fun. So I don't know if any of you guys have seen Hamilton, but I went through a little phase where I was obsessed with Hamilton. And so I wanted to test something handwritten. So I went on the website, like on one of the government websites, there was an actual copy of the letters between Alexander Hamilton and Angelica. So I read all of them. And then I copied just select portions. So that is Jennifer Marsman's handwriting, not the actual Angelica's. But I copied it onto a note card that I had. And then I put that in there because it's an interesting problem of can it both kind of do the OCR-like stuff that it has to do, plus the semantic understanding to do the summarization like in one pass, right? That's an interesting problem. So I tried that, and it did a very good job, too. So those are just some of the tests I ran that I thought were of particular interest. So now let's focus on Wordle, the good stuff. OK, so again, I've kind of explained Wordle was this spot of joy during COVID. If you have not played, how many people have played Wordle before, just out of curiosity? Nice. OK, most of the room, but not everyone. All right, so for those of you who have not played, the way it works is you have 6 guesses to guess a 5-letter word. And every guess that you put in has to be a valid word. So if I want to see, like, if it's something like, I don't know, that eerie, and it could be like, I don't know, like other things. If there were, like, let's say 4 other letters where it could be the right thing, I can't just type in those 4 letters in another one. I have to choose an actual word. You can't just put a random collection of characters in there. And then after you input a word, what will happen is every single letter in the word will change a color. If it changes green, that means the letter is in the word and it is in the correct position in the word. If it turns yellow, it means it is in the word, but it is not in the correct place. And if it turns gray, that means that the letter is not in the word. OK, so each one of those things gives you information back. All right, so why, Jennifer, did you choose to do this? Why did this even make sense? So much like that Eliza letter that I did, or I'm sorry, Angelica. But what I liked about it is that it combined 2 different things, right? With that Angelica letter, we were combining kind of OCR plus a summarization, like, together. And what was exciting to me about Wordle is that it is super duper hard to do, like, 3 visualized things, and we have to have, like, localized things within the image all in a single pass, because you have to really know 3 things visually, right? You have to be able to do the OCR type stuff to get all of those characters out of the image. Then you need to extract all of the colors, right, for each character specifically. And you need to know the relative positions, right? So, like, if it's a yellow one, it needs to go somewhere else, for example. So, and then there's all the logic of the actual rules for the game. So the position is hard. Like, a lot of these things are really, really hard. So this was something where I'm not quite sure if this is possible or not. So that's why it made a really fun exploration. And so for the rest of this talk, I'm going to take you through the prompt engineering techniques I used to be able to try to solve this. And then the last thing is that it's just fun, right? I had a ton of fun gathering training data and, like, playing Wordle every day and taking screenshots so that I could use them later. And then if you do go to the code repo, there are a bunch of sample boards in there that you can use. Limitations, so this is something that was published on the OpenAI website when the first release of the GPT-V preview came out. And notice, especially here, that it does say that it struggles with tasks requiring spatial localization. So spatial reasoning has historically been hard for all large language models. So that's another one of the things where I was like, I'm not sure if this is going to be possible, but let me try it. All right, so what I'm going to do for the rest of this, I think as a demo person, as someone who loves building demos and does that for a living, a lot of times what people see is, like, the final perfect polished product, right? But the actual interesting part is the journey to get there, because it's really, like, all the things I learned along the way, like, that's the stuff that was actually really interesting about building this. So that's what I want to do with this talk, is I'm going to actually start from the very beginning. This is basic hello world. And then I'm going to walk you through everything I tried and all the things that failed as well. So that's what the rest of this talk is going to be. All right, so just to get started, what I wanted to do is basically the hello world of image understanding. And that is, you pass in an image and you say, describe this image, or what is this? All right, that's the hello world of image understanding. And so I passed in this image right here. I did actually crop it like it's a cell phone, but I had passed it in as a landscape thing because it was from my laptop at that point. But this is what the model's output came back with right here. And so this actually gives me some good information. So number one, it tells me that the model knows what Wordle is, right? I understand that Wordle is an actual, like, in the training data, it seems to understand the rules and logic of Wordle, which is good, and it recognized that this was a Wordle board, which was good. And it actually pulled out all of the correct words, right? You see that rates and climb and phony and fudge were all guessed, so it was able to extract all of those words, so that gave me something positive that, okay, it seems to be able to do that. But there was a lot of stuff that was incorrect as well. So all of the yellow highlighted items are things that are not correct about this response. So it said for rates that none of the letters were in the correct spot, and that is incorrect. The E is correct as is turned green. And then it messed up the L and the I right here. Essentially, it transposed those because it thought that the L was yellow and that the I was gray, and it was actually the opposite. And then here, so all of these, everything highlighted here is not actually correct. So we have a little bit of work to do, guys. So let's see what we should do to start. Now, some of my colleagues, so I had released, when GPT-V first came out, I had released a whole bunch of scenarios and kind of showed people the work I did and published something within Microsoft. And then some of my coworkers in Microsoft Research did an exploration as well, and then they ended up publishing theirs externally. And so if you take a look at that, there were some things that struck me as similar to the problem I was trying to solve. So I took a look at that. And so let's actually dive into that research paper here. Oh, this is my code repo, by the way. It's github.com, Jennifer Marsman, Wordle GPT. So you guys can check that out later at your leisure, and I'll have that link again at the end. And then here is the paper that my coworkers published. And what particularly I want to show you, this is some example of few-shot learning. So if you've seen any of my other machine learning talks, you know that this is one of the first techniques that you try, right? If something doesn't work out of the box, then let's give a few examples to kind of guide the model to the right answer. And it's very easy and cheap to do, so that's a good place to start before you jump into things like fine-tuning or RAG or other things. If few-shot works, that's probably the simplest. So I'm going to give this a try first. And so this thing that they were working through at Microsoft Research seemed to be a similar level of complexity. So they were trying to read a speedometer, so another image understanding problem. And so notice that this one was not correct in this very earliest version of GPT-V. So don't, again, remember that this is not all true today. This is what was true at the time. But looking at this exploration, all of the prompt engineering techniques are still going to hold true, though. So the lessons learned are still going to be accurate. But the state of the model has changed. So right now it says, what is the read of this speed meter? And the correct answer was around 10, you can see. And it did not get it right. So everything here that is highlighted in red is incorrect. So you see a zero-shot prompt where we just ask apropos of nothing what the answer is. It was not able to do. So you can you can kind of ask it to try to do a little bit more chain of thought reasoning by telling it to think step by step. So if we do what is the read and let's think step by step, you can see it does a slightly better job here where it tries to think its way through the answer. It noticed that there's two scales, and this is not correct. The between 20 and 40 is not correct, blah, blah, blah. It did actually use the information here correctly because it said 30 if it was halfway between. But yeah, that is not where it reads. So not good still. And then this gives text instructions. So we've added to the prompt to read this speed meter. Observe the needle on the outer edge of the dial, which points to your current speed represented in miles per hour. Yellow is the color of the needle. So we're giving it a little bit more guidance there. And it still is not able to get it. And now if we combine those two techniques, let's use the text instructions and the think step by step. Let's see how that does. And then here you'll see that, again, it's actually working through the steps correctly. It's kind of giving some good steps, but then it does not get to the right place at the end. So it just seems like that was not possible quite yet. So now we're trying it with few-shot examples. So what that means is we pass in examples of here's what one input and its corresponding output should look like. And this is a really effective technique because it's if you use that kind of as the chat history, you're guiding the model in the right way to respond, how you want it to respond. And since down at the core, as you've seen in some of the other talks here, all we're doing is generating the next tokens, right? So using that technique, that helps the model get to the right place a little bit better. So this is a very effective technique. So we're going to ask now, what is the read on this speedometer, pass in this image, and then give the correct response, which is the yellow pointer is roughly in the middle between here and here. So that's 90. It's a little bit past the 90, so it should be around 91. And then we do this one, and then we say, in this image, the yellow needle is roughly ... and the model continues, and the model got it wrong again. So that did not work. And then again, we tried a couple other little things here. And then in this case, we now changed it to 2. And what I like, it's always important when you're choosing your few shot examples to represent as much diversity in the data as possible. So what I love about how they chose these is that notice how one of them is pointing one way and the other one is pointing the other way. Because when you think about like the edge of the dial, like it needs to know to look at this edge rather than the other edge, right? And there's nothing like inherent to kind of tell you that. So the fact that it chose one where it was pointed this direction and the other one pointing in the opposite way, I thought was really smart. So this, and then notice that it did actually get it with the 2 right there. So all the key takeaway from all of that, just to kind of walk you through that example, is that this is something that is possible to do with. Here we go. This is something that is possible to do. So my first insight was, OK, if it doesn't work for 0 shot out of the box, then let's try few shot examples. So I added some of those to my prompt. So with the initial try, when I tried few shot prompting, so I had copy and pasted. I've been saving up some Wordle screenshots, so I started passing them in and then giving the correct answers there. And when I tried that for the first time, it got some colors wrong, some positions wrong. It did get the characters right on the very first try. But the thing you have to remember with generative AI is that do we just run it once and assume that's what it always will do? No, never. You have to run it lots and lots of times and take an average just to see what's actually going. And if I'm presenting anything in front of a customer or in front of end users, like I run it a lot in advance just to kind of get a sense of the range of what can come back. And then once you do that a lot, you become a lot more comfortable with the model's output and kind of where the guardrails are. So really, really interesting stuff. So the very first run, the character extraction was actually right. But then after that, it actually kind of went down. OK. And then actually, I kind of want to show you the code. I forgot to set up my code. Extract Wordle info, few shot. Let's just grab it from the GitHub repo. I can probably just do it there. OK, find, extract. Well, yeah, this one. OK, so here's kind of what the thing looked like in case you're wondering. Let me just kind of zoom in a little. This is just what my prompt looked like. So I was saying, focus on the letters in the colored boxes in the center of the image. List all letters in green boxes and what column they are in their row. List which letters are in yellow boxes. Notice that I used characters, or I used letters here. Oh, I guess I used letters here as well. OK. And one of them I switched between letters and characters just to mix it up. But I guess it wasn't this original version. I might have added that later. And then you have to base 64 encode the image. So I did that. That's just how the API takes it. I have my 2 sample images. All of those things are found in the repo. I pass it in here. And then calling the vision model, this is what it looks like. This original content was you are a Wordle AI assistant that identifies the letters already guessed, what color they are, what character the position is. And then you already saw my user prompt above, and then I just passed in the image. So this was sample 1, and then I gave like the output I wanted, and then example 2, the output, that was correct, and then I passed in my last one, and then called with that, OK? So that gives me my few shot examples in there. All right, so pretty straightforward. Nothing too crazy yet. OK, so we saw that colors were wrong, positions were wrong, extraction was right the very first time, and then extraction was wrong too. Like after I ran it like 10 times, it was wrong. I don't remember, but like 8 out of the 10 kind of thing. So I was like, oh, I just really lucked out on the first one. So this example didn't get the Y right. I ran it some more. It just wasn't working. So this got me thinking, where I started thinking about how the model represents language, or like what is the unit that the model is using under the covers, right? So we're going to do a quick little sidebar on tokens, characters, and words. So hopefully everyone in this room knows what a word is. So I'm going to give an example. The word standoffish means aloof or a little stuck up. And then you can character break it by each of the individual characters within standoffish. And then the way you would tokenize is it actually kind of grabs little concepts like within the word. So if you run, this is the tokenizer that is available on the OpenAI website, and you can actually run a word in there and see exactly how that word will tokenize, which is kind of neat. And you see that that actually breaks off into standoff-ish, because those are like the separate concepts within that word. Same thing with an apostrophe S, like a possessive will tokenize by itself, because that's a concept you could apply to a lot of different things. So that tokenizes together. So really quickly, I can just show you that on the site. Here is the live version of this. So you can put in something like Jennifer's queen-like behavior. Oh, sorry, should I spell it the British way? There we go. There we go. So now you can see that it actually did Jennifer tokenized by itself, the apostrophe S for the possessive tense, or the possessive, I don't think that's a tense, but the possessive tokenized by itself. Queen, like is very similar to ish, right? It's the whole little having the properties of. So that tokenized by itself, and then behavior all chunked together as well. So I started thinking about this and how, okay, the model is seeing tokens, right? That's what the unit is. So how is it knowing, like when it sees like the words and characters, like how can I get it to turn those into characters? That was really the problem that I was dealing with there. So, and there's actually a sample here. You can go to samples and it shows how they do, or you can just put in whatever you want here. So feel free to check that out if you would like to learn more about tokenization. All right. So, and then here are the examples that you already saw. Okay. So I was thinking about this, and I was like doing a bunch of searches trying to figure out how do I tokenize these characters so that they tokenize individually. And I actually got a hit from Andrew Main. So Andrew had a similar job to what I did at Microsoft. Andrew was doing at OpenAI back at this, or a little bit before this time frame. And so he had actually published a blog post way earlier. This was before the visual capabilities came out, but I think it was just trying to solve it like using text only. And so you can go read his full blog post if you would like, but the main insight in there is to put brackets around the characters, and then with that bracket, imagine like internet scale data that these models may have been trained on. We understand, like when processing things, that brackets around something makes them kind of go together. And so just by putting brackets around the characters, that allowed it to tokenize as a single token. So yes, so I tried that. So what that looked like here, so I had my system prompt. This is exactly the same system prompt that I just, well, it's a little bit extended, but this is what my system prompt looked like at this point in time. Here's what you do, and then I did actually add a whole bunch of color information in at some point on like what the various color values were, RGB and hex values and such. We'll get into that later when we talk about color. And then the user prompt. So here is a new image. I actually put that in at one point because when you think about it, if I'm doing few shot, remember I'm showing it an image and then saying, H is yellow, da 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 da. And then I'm showing a new image and then a new thing. So I didn't want it to like pull forward from the chat history the fact that H is yellow, for example, if that was specific to one of the images above that. So I did like modify my prompt at the very beginning to say, here is a new image so that it knew to kind of like clear the buffer. And then I said, focus on the letters and colored boxes at the center of the image, find each green, each yellow, and each gray, and identify their letters kind of deal, okay? And then when I did my few shot, here's the key difference. I now have, I now have brackets around each character. So the image looks exactly the same. I'm passing in the same image. You don't have to do anything fancy with the image or modify the image. But when I'm pulling it out, I'm saying Y, and then putting brackets around each one of these characters here. And it worked! Yay! We've got 1 out of the 3, you guys. Check. We can put a big check next to that. So it is extracting characters correctly now. But colors are still not working and positions are still not working. Okay, so now we gotta move on to the next thing. But that trick in itself was enough to do that. So, and then again, I ran this lots and lots and lots of times because generative AI, this is how we work. And it was consistently getting the letters right, but the colors and positions were not always right. Okay, so I had a lot of other insights. We're gonna kind of do a montage here of like thinking and kind of pull out some of the interesting stuff that happened. So the first thing was chaining. So I was like, okay, maybe the model can't get this all in a single pass because we are asking it to do a lot of different things in a single pass, which can be difficult. So I thought about, okay, do I need to break it down into multiple model calls? So if I can do characters consistently, maybe that's one pass and I get that first, and then I call the model again saying, okay, for this character, what color is it? Like that sort of thing. Maybe that chaining thing would work. So that was one idea. And then the other thing was one of those 3 in the morning revelations that I was like, oh, this is stupid, Jennifer. Why didn't you think of this earlier? And that is the fact that long before the days of generative AI, when machine learning people, data scientists, one of the problems that has always been true in machine learning is that asking an open-ended question is harder than doing classification, choosing between known buckets. So if I say, what color is behind this character, I have this whole spectrum to choose from. But if I say, is the color closest to green, yellow, or gray, I want one of those 3 answers, like that is a much easier problem to solve. So I was like, oh, let me rework my prompt to be a little smarter there, because that's something that's always been true for ML. All right, so those were 2 big insights, so I incorporated those. So this is kind of what my new pseudocode looks like, and you can find this somewhere in the ugly repo. So I'm calling the model to get the characters in a first pass of the model. Then I'm parsing out the JSON and such to grab all those individual characters, and then parse out or I have to take the brackets out, and then be able to call it individually for each letter. So then I would make a bunch of calls to the model individually saying, what is the color on this particular character or behind this particular character? So I tried that and meh. I was so excited, but nope, didn't work. It still was only getting about 3 out of 5. It was not really it was not consistently doing anything. So nope, that was not helpful. So the chaining by itself was not doing it. You can see some of the output there, and yeah, that's not correct. So there was actually a different part in the same paper that caught my attention and got me thinking again. So there was a section on dense captioning. And I don't actually care about captioning in here, but the dense part was interesting. So what I mean by that is, in this same paper that I was talking about earlier, they had a prompt right here that actually says, please follow the instructions, tell me the size of the input image, localize each person in the image using a bounding box, recognize each person, and then generate a detailed caption for each bounding box, okay? So this is a picture of 4 luminaries in the AI world all together. And it is able to recognize and do a little caption for each of them in this example. And so I was like, because again, we're doing this, it's localized, right? It's being able to find something within the image and have the model focus on that. So I was like, let me just try and explore using kind of the way that they were doing it. And then notice too, for that instruction number 1, tell me the size of the input image, the image model actually has no access to metadata, so there's no way it can get that right. There's no metadata from the image passed in. So that it consistently gets wrong, as you can see from the little red bits there. So what I did here was I actually changed the wording. So look at the user prompt here. I left in my here is a new image, because I think that's still important, right, because of the few shot. But then I said, please follow the instructions. Focus on the letters in the center of the image, because remember, there's a little keyboard underneath. Localize each colored box containing a letter using the bounding box. Identify it as, again, using my classification here, identify it as green, yellow, or dark gray, and then identify the character and the position, okay? And, my friends, that worked. So I was consistently now getting the correct characters in the correct positions. Why did that work? Do you guys get it? To make it a little more clear, let me back up a second. So notice what I'm doing here is I'm saying focus on the letters, localize each colored box in the letters, identify each box. So I think the reason why this worked, once I kind of stopped and stared at the diff between them, was that I'm kind of letting it process things in order, like in a semantic understanding that is order. It's like getting to scan the image like in a way that it's comfortable with. If you look at what my previous prompt actually said, we're going to back way up, sorry. My previous prompt looked like this. And notice that I said, focus on the letters, find each green box and identify the thing in front of it, right? So it's like jumping, having to look all over to find all the green boxes, find each yellow box, and then find each dark gray box. So I honestly think it was just by swapping the order of those things, by kind of letting it do that the positioning kind of fell out of that because I was letting it work in a way that was more natural. Does that make sense? That's my hypothesis on what actually was happening and why that prompt was better than the previous one. Make sense? Cool. All right. But again, it was one of those things where once you saw it, it was like obvious, but like before that, it was crazy. Okay, so now, where were we at? We were right here. So this is the new one. This the dense captioning thing that has nothing to do with captioning, but I changed it to my scenario, and now it worked. So we are consistently now, we have two things right now. Using those prompts, I still have the brackets and stuff. We now have correct characters, check. We have the correct positions, check. The colors are still wrong a lot. So that's nothing. So we got a yes, and a no. We're 2 out of 3 now. I tried this lots of times, and it was not working still. OK, so we're still thinking about colors. How do we get to the right place in the correct position? And what I messed around with so many things, you guys. So I kind of went through the same mental exercise that I did when I was thinking about the tokens. Like, how is the model representing this under the covers? Like, how is it representing color? Like, could it be the hex values, the RGB values? Like, what are the different things? So I tried a lot of different investigations to try to nail this. And then actually I was calling, like, this is just calling ChatGPT, which at the time was running the exact same model. So if I just said, hey, what is the base 64 encoding of this? And then just to see, like, does it know? And I'm like, OK, it does have that knowledge in there somewhere because it is able to come out with the right values for these things. I was looking up hex values and RGB values and stuff. So like it had the knowledge inside of it, but I wasn't able to get it to do that localized extraction of the color effectively. And but we saw from that bridesmaids test at the very beginning, right, that the model can do color. So why couldn't I get it to do that all? So what I decided to do next is, like, my hypothesis was maybe it just can't do all of those things in a single pass, right? That may not be possible to be able to extract like all of those things like all together in a single pass. So there's an easy way to test that, right? And that is by isolating one of our variables, okay? So instead of asking it to do the position and the color and that, like, let's take position out of it for a second. So that's easy enough to do. I just wrote a little bit of Python that chunks up the thing, and it was super easy because it's always a 6x5 grid, right? Because you always have 6 words and 5 characters in each word. So wrote some Python that just did the chunking to make each one of those things individual, and then passed that in, each little tile colored box in separately, just to see, like, OK, can I do that? And it worked. You can take a look at the results right there. But when I use the code, so this is not the model doing the chunking, but my Python code chunked up each thing and set it individually. And I can consistently get both the characters and the colors. So it may be that you can just get 2 out of 3 at any given time based on things. Yeah. All right. So that is how that works. So now we see that the model can actually recognize color, and that it just may not be able to do all 3 of those things as one pass, which makes sense. OK, so then the next thing to solve in Wordle is how do I choose which word to guess? So now I have all the visual information I need to be able to do something interesting, right? So there's 2 different ways to guess the next thing, right? Number 1, you could have the model do it, or you could use code. All right, so I tried both of them. So here is my, like, a quick example. This is a very, very early example where I was still using, I think, GPT-4, it looked like, from right there, to be able to ask the model to do it directly. So you can see my prompt there. I said, hey, you're an expert here. See what you can do. Here's all the stuff you know. What should I guess next? And at the time, again, this was an older model, it didn't do a great job. Like you can see the results there, and there were a lot of things. I kind of wrote out at the bottom everything that is wrong about that answer. It forgot it didn't see M in there, the B is not right, and then those two of the guesses it gave were not actually good guesses given the constraints that we had. And it spelled fourth wrong for some reason, which was weird to me because I thought that fourth, like go forth and conquer, would actually tokenize differently than fourth, like 3/4, you know the actual number version. I figured those were different tokens, so it was weird that it used them interchangeably for some reason to me. Okay, but fast forward to where we are now. This is obviously possible. So like the O1, if you use like a reasoning model like the O1 models, this can handle it very easily. So here's a sample input. Here I'm playing a game of Wordle, and this is what my prompt looked like. The R was yellow. I just kind of spelled out what everything was. And then I ask at the end, what is an optimal word to guess next that will solve the puzzle or help me gain the most new information? And if I put that into the O1 model, it gave me this particular output. The output was, from a strategy standpoint, you want to keep the known E in the fourth position and probe as many untried likely letters as possible, especially because you know that R can't be here and O can't be there. It got all of that right. And then it said a strong candidate that makes that thing is coder. Nice. And so that was actually true. And then, so yes, that is a good guess given that thing. So, and I've run that again multiple times, and it does do a good job there. So that is something the model can do. But remember back here, so there are two ways to do this. And when I was first giving this talk, the other point I want to make is that just because you can do something doesn't mean that you should, right? So there's a lot of times when I see, like, and I'm guilty of this too because we're all geeks and we love to geek out and we love to use the latest cool technology. But sometimes it doesn't make sense to use the model to do things that it's not inherently good at when you can do the same things like very cheaply on like a CPU. So like math is a great example of this. So sometimes you need just code, right? And what you can do is, when you think about a scenario like math, okay? So math, you can do like so cheaply on a CPU, and it is highly, highly accurate and will always get it right, like within the limits of floating point math, right? But so very, very high precision there. And, but would you ask a model to do math the same way? Like it may or may not get it right with that level of accuracy, and you are using GPUs or sometimes multiple GPUs to do this. So it's kind of a matter of like use the right tool for the right job. And I think all of us here are probably either are building products or we are selling to people or trying to become trusted advisors to some customer or client or whatever. And so like I would have a hard time going in front of my VPs or the CTO and saying, yeah, like we need to use, all of these expensive GPUs to solve this problem, like to guess the next word in my Wordle thing. It's not a good example of when to use a model, okay? So especially given, so in your day-to-day lives, as you think about how to apply this to like real world scenarios beyond Wordle, like think about, is there existing code that already does this in my code base? If so, cool, like that's why the model has extensibility points. You can call out, invoke existing code that maybe is already battle tested and that sort of thing, and then get those results. So you don't have to use the model for everything. You can use these extensibility points. So just remember, just have a little Ken on your shoulder that's singing and dancing and saying, it's just code. If you can do it easily or cheaply with code, like use a plugin or whatever we're calling them nowadays, okay? Plugins, functions, skills, actions, like we've had so many different names for them. But there are extensibility points with these models that allow you to call out to a REST endpoint, invoke some code, and then like get that back, and then the model can use that output. So that can be great for combating weaknesses, like with math, for example, to augment value and to do things just cheaper, right? And more environmentally friendly way. So always something to keep in mind. All right, and so there are a lot of existing Wordles, so I wanted to take my own advice on this and also create a teachable moment for the people I was doing the talk to the very first time. So what I did was I actually went and looked at a whole bunch of different Wordle solvers that were out there, and then there was one that I liked the best, And I want to give credit to the algorithm belongs to someone else, but then when I went back to grab the code, I could not find it. So I ended up recreating the code for the algorithm myself. So any code mistakes are completely Jennifer Marsman's fault, but I do want to give credit because the actual algorithm was not my original idea. I went and looked at a bunch of stuff and found someone else's idea, but yeah, and I couldn't even think. And then I do want to give credit to Tab Adkins, whoever they are. They had all of the Wordle, words listed in a GitHub repo somewhere with license that allowed you to use it. So I grabbed it from their repo. So that is just the word list was from this repo. So thank you, whoever you are. And then there's no support for functions yet, so I was just like making a call to the Wordle solver logic, but the right way to do that, the clean way to do that is to use kind of that functions and that extensibility infrastructure when that now exists. Okay? And it worked, you guys! Woo! It all started working together. We were getting everything. We were getting some good valid next worked. I did a bunch of tests on like multiple yellows and stuff because that's really tricky, and it was doing well. So, moment of truth, you guys. Let's go ahead and we will try to do this live with my code. So I'm just running this code right here, this repo. It's a nice little Gradio thing. And then I have a second guy right here. Let's see if we can line these up a little more. Yeah, let's do something like this. We'll need this. We'll need this. There we go. And then we'll also need to see the anaconda if you want to see like actually what's happening. Okay, so what I'm gonna do, my best strategy, I've spent way too much time thinking about this, you guys, but my strategy is that I usually guess rates first. That's my favorite start word. So every single day I guess the same start word because I'm very boring. But this is the one that I feel like is totally optimized. Ooh, it's very optimized today. Actually, this demo might be a little too easy now. Man. Okay, hopefully it's okay. But what we're gonna do is now we're gonna copy this. So I'm just gonna use, take a little screenshot here of what we got. So this is what we have so far. And then here in my Gradio, you can actually upload a picture. So if you want to use some of the images that I have in my GitHub repo, party on. You can try, play with those yourself. Or this allows you to paste right there. So you can click that little button to do the paste. And so that pastes in rates. And so now what's actually happening, I have some debugging info that should come back here. And we are on the demo Wi-Fi, so please be kind. Don't like stream YouTube right now. So we are going to see this coming back. And you can see the R came back as dark gray. Yes. The A came back as green. Yes. Yay. This is correct. And we have a yellow E and a S. OK. And then it's using the logic in the code that I wrote, which is really a regular expressions thing. So now we have all of these valid words to guess. What looks good, you guys? Anyone have any one that they want me to use? Labs? Which one? False. False? OK. False doesn't seem, there's not that many other Fs, though. Is that a good one? Oh, whatever. OK. Yeah. You guys! Yeah, we got it right, but that didn't get to show you that much stuff. OK. But all right, so if we would have put in other guesses as well, it also would have given, like, narrowed down the list. Sorry, that was a little too easy. Now I don't even get to run it again. Boo! Oh my gosh, you guys, I never get it in 2. This is so exciting. But not, yeah. But anyway, so what we would have done, I don't think I can redo it because it's cached. Will it let me? No, it's, yeah, so I'm using incognito now. Let me see if it stores that or not. If I go back to it, will it let me do it again? I'm not sure. Sorry, that's not incognito. Here in private window and Wordle. Let's do, sorry, it's bringing up my GitHub. New York Times Wordle, there we go. Will it let me continue? Yes, see, this is being in the, yep, thank you. You guys are, Okay, yeah, all right, awesome, all right, cool. So we could do it again. So if we choose one of the other ones, sorry, what did I have? I had rates, and then we could do like, I don't know. So now it's like, now I know, so it's not as fun. But if I did something like, I don't know, cause, sauce, sure, I'll do sauce. Sauce, you can see it like working again. It's not an S. All right. And then we paste that, and then you'll again see kind of the things flying by and it all working. All right? But this one, you're welcome to download this. You can try it yourself. You can see kind of the different things that you can do. With O1, too, you can actually just ask for like the best word, like I saw, because like the model can actually do this. So you could either write more code that just gives you one answer if you just want to know what is the most optimal one. That's super easy, and then O1 is actually super good at that as well. Any other reasoning models can do a really good job with that, too. So we can let that trigger away, but you can see it's getting all the right things. Here's our S is yellow, our A is green, our U is dark gray, and our C is dark gray. And one more, E is green, and now it should give me my results back. So it was able to narrow it down. And false is still in there. Okay, but yay, we know it's false, so I won't continue, but yay, okay. So we were able to solve the Wordle correctly, woohoo! All right, so if you would like to go ahead and try this stuff out yourself, and then I also did the very, very thing that I know a lot of developers hate. I left, like, every time I tried kind of some new prompts, I left old ones in there, so I would create a new method and do things just so that you could see the whole journey. So again, it's a really ugly repo. Don't use it as an example, but it's really just more to show the journey and the things that were tried and that sort of thing along the way. So as you see, like the different steps I went through in the prompt engineering, a lot of those are in that repo. And do remember to follow the best practices that did not exist when I was building this. So use a framework. You can use a different orchestration layer if you'd like. There's a lot of great ones out there. You can use chaining and other things. You can use functions or plugins and all of that good stuff. The 4.0 model does support these things now. So use 4.0. That's now the state-of-the-art model here. A couple other resources I want to call out. OpenAI did release a vision guide, which is great. The research paper that I showed is right there, so you can check that out. There's actually a lot of really cool stuff around if you're using image understanding at all, some really good stuff in there. And then the Azure OpenAI docs are really good, and the people that create those docs are like doing a phenomenal job. You can usually guess, like if you go to aka.ms OAI docs, that's the documentation. If you want to know the pricing, it's aka.ms OAI pricing. If you want the model information of like what models are available in what data centers and what's their training cutoff date and all that good stuff, it's aka.ms OAI models. So like they documented it all pretty well, and it's all good stuff. My code repo is right there. And if you have learned nothing from this talk, but you're like, hey, that Wordle game looks kind of fun, I'd like to play that sometime, there's a link to play Wordle at the bottom too. All right. Thank you so much. There is a great .NET 9 is out, and we have a wonderful Microsoft booth on the 5th floor that you guys can feel free to go check out. And you can actually request time with speakers as well, so feel free to use that link and ask for time with people if you would like. And I appreciate you taking the time, and I'm happy to take any questions. Thank you guys so much. Any questions? Yeah, go for it. There's a mic right there, just so that I think it shows up on the thing, or I can